Hey everybody, in computer science principles, Mr. Bigelow here, and today I'm going to be walking you through Unit 5, Lesson 5, to introduce you to the idea of loops in JavaScript. So we have one command here, move forward, and this command moves the robot one space forward in the direction that is facing. So let me kind of back up a second here. Today we're going to be using kind of robot coding, which exists in a world that is built up of a 5x5 grid with one triangle that is the robot. It's not actually a robot. We're not gonna be like studying robotics or anything, but it is facing a certain direction, and that direction is denoted by this little arrow, and it's kind of what direction the triangle is facing. And if we have a command called move forward, it moves it forward one square or one space in that direction. And this is a way that we can learn some concepts with coding. We're going to use it for loops today. So let's say that we had move forward, move forward, move forward, move forward. As you can see, the robot moved forward 4 times to get to the spot where it is now. So that's what that code does. This code is repetitive, so how can we simplify it? We can use something called the while loop. We're going to learn about 2 different types of loops today, and the first one is the while loop. So the while loop works like this. While something is true, the code in the while loop runs over and over until that thing is no longer true. Here's a very, very simple diagram of what we're talking about here. So the code starts up here. We get to this diamond. And if something is true, if the Boolean in that statement is true, then the specific code runs and then we repeat and we come back up here again. And if that statement is still true, we're stuck in this loop until whatever's in here is false, then we move on. I'll show you what it looks like in action. Okay, so we have this variable called steps, and steps equals 0. While steps is less than 4, we are going to move forward and then add 1 to steps. Remember, steps plus plus means we take the variable steps and add 1 to it and replace the number that was in there. So we're going to follow along with this program. This says on your own game board. You don't have a game board. We're just going to do it together. So let's see. Okay, so round 1. Steps is 0. While steps is less than 4, well, we check. And steps is 0. That is less than 4, so it's true. So we're going to move forward, and then we're going to add 1 to steps. So steps is not 0 anymore. Steps is now 1. Round 2. So now we have steps as 1. We check. Is step still less than 4? Yes. So we're going to move forward 1, and then we increase the value of steps by 1. Round 3. Now steps equals 2. Is step still less than 4? Yes, we're true. So we do this code, we move forward 1, and then we add 1 to steps and replace it. Round 4, is step still less than 4? Yes, that's true. So we're going to move forward 1, add 1 to steps. And round 5, is step still less than 4? No, we are false. So since this is the first time this Boolean statement returned false, we get ejected out of the while loop. The while loop stops, and we keep going with the rest of the code. In this case, we're done. So this is a way to simplify the idea. Instead of just having moved forward 4 different times, we can only have it written once with this while loop that kind of makes it happen 4 times, okay? Let's try this again. So now we have a new command, turn right. So now we can either move forward or return the robot right 90 degrees. So let's see what happens here. We have variable steps equal to 0 again. While steps is less than 4, we're going to move forward, turn right, and then add 1 to steps. So let's see this in action. Okay, after round 1, we moved forward, turned right, and then now steps equals 1. So I'm going to keep track of that. Steps is now 1. After round 2, we moved forward. So we were facing to the right. So forward is now this direction. We turned our robot to the right, And now steps gets added 1 to it, so now our steps is 2. Next step, same thing. We're going to move forward, turn right, add 1 to steps, so now steps is 3. And now we are going to do the same thing again. We're going to move forward, turn right, add 1, and now steps is 4. And if we start it over again, remember it's while steps is less than 4. Well, now steps equals 4, so now we're done. So we get ejected out of the while loop, and you can see we ended in the exact same place where we started. So we just made a big circle, but that's what happens, okay? Okay, so while loop has 3 parts, and we've been using this whole time, but let's kind of go over this. 3 parts are a counting variable set to an initial value, in this case, steps equals 0. A Boolean expression which checks the condition of that variable, that's right here. And a statement which increases or decreases the variable that is being checked. That's right here. Note, if this piece is missing, we may accidentally create an infinite loop that never stops running or crashes your browser. So if we aren't increasing the value of steps every time, steps is never going to change. So steps will always be less than 4. So we're just going to move forward infinitely. We do not want that in this case. So we don't want to do that. All right. But that's the 3 parts of a while loop. Next up, we're going to talk about a for loop. So a for loop combines these 3 parts into one statement, right? So instead of saying there's a separate variable that equals 0, it's going to be built right into one line of a for loop. And any variable name can be used here, but it's most common to use I. So it's really common to see var I equals 0, just like this. The part where we say steps is less than 4, the Boolean, is the next thing put into the for loop. And then the last part where we add 1 to steps at the end of each line in the while loop happens next all in one line in the for loop right here. Again, we almost always use I. So the only thing we're going to be changing if we set this up is what number goes here instead of 4. We just put the number in there for how many times we want this to run. And then this will happen that many times. Also note that a loop is an example of iteration. Iteration is a repetitive portion of an algorithm which repeats a specified number of times or until a given condition is met. All right, let's keep going. Okay, we have one more new command, turn left, and does exactly what you would expect. This command turns the robot to the left 90 degrees. So let's try a new piece of code called the for loop. I'm going to keep track of the value of I on this little piece of paper down here, this little post-it. So we see that so we have a for loop. And remember, there's 3 things happening inside of this loop. We've got, first of all, the initiation of this variable I. It starts at 0. And as long as I is less than 3, this code's going to keep running. And at the end of each time this code runs, we're going to add 1 to I. So first, we are going to say that, okay, well, 0 is less than 3, so we are going to run this at least once. So we're going to move forward, turn right, move forward, turn left. Okay, so that was the end of round 1. And after we run through this code once, we take the value and we add 1 for I. So now I is 1. 1 is still less than 3, so we're going to do everything again. Move forward, turn right, move forward, turn left. And at the end of every time that we do this in a for loop, we do this last piece of code from the for loop again, which is, again, to change the value of I. We increase it by 1 to 2. But 2 is still less than 3. So we're going to do this again. Move forward, turn right, move forward, turn left. And then we change the value from 2 to 3 for I. And now 3 is not less than 3. So we exit the loop. All right, hopefully that makes sense. And that's where we end up. Let's try another one. For the var I equals 0, so again, we have this I that we're setting up here. If I is less than or equal to 2, we run the code. And every time after we run the code, we're going to increase the value of I by 1. So let's start. First of all, 0 is less than or equal to 2, so we start with the code. We move forward, turn right, move forward. And we ran through it once, so we changed the value of I from 0 to 1 because of I++. And 1 is still less than or equal to 2. So we do this again. We move forward, turn right, move forward. And we're going to increase I by 1 because of the I plus plus. 2 is still less than or equal to 2, so we do it again. Move forward, turn right, move forward. All right, then 2 changes to 3. 3 is bigger than 2. 3 is not less than or equal to 2, so we stop. Okay, now we can make this a little bit more challenging. We have these barriers, which are represented by these gray circles that can be in our grid with the robot, and we have walls on the edge. The robot cannot move past the edge of the grid. And there are new commands: can move left, can move right, can move forward, can move backward. These evaluate to true or false. They are dependent on the direction that the robot is facing. If a barrier or a wall is in the way, the Boolean expression evaluates to false. So it is a Boolean expression. All right, let's keep going. So in this context, if the robot is situated right here facing up, it can move forward. So can move forward would spit out true. It can move to the right, so that's true. It cannot move to the left because there's a barrier, so that would be false. And it can move backwards, so that would be true. In this context, we can move forward, so that's true. We can move to the right, so that's true. We cannot move to the left because of the wall here, right? Because we're at the edge of the grid, so that's false. And we cannot move backward because of a barrier, so that's false. All right, so let's try some new code. We've got this whole new for loop here. Again, the variable I is being set up as 0. As long as I is less than 3, this code is going to run, and we're going to add 1 to I every time. Okay, so you can see how we are going to use can move. We put it in an if statement to know if we're going to do this stuff. So if we're starting right here, I is less than 3, so we start and we run the code. If we can move right, well, if we're situated right here, we can move right. So we're going to do this. We're going to turn right and move forward, turn left. If can move forward, okay, we cannot move forward now, so we don't do that. So we're stuck right here after round 1. Then we increase I by 1. 1 is still less than 3, so we keep going. If we can move right, which we can, we're going to turn right and move forward. We always turn left then. If we can move forward, which we can, then we move forward. Okay, so after round 2, we actually did every single bit of code here because all the if statements came back true. So we turned right, we moved forward, we turned left, and then we moved forward. We're going to increase I by 1 again because of this I plus plus that happens at the end of each time we run the for loop. And now 2 is still less than 3, so we're going to do it again. If we can move right. Now this time we can't move right, so we're going to skip the turn right and the move forward. We always turn left. And then after we turn left, we're going to have to check if we can move forward. So let's try this. We can't move right, so we turn left. We can't move forward, so we're stuck. We also don't do this code, so we stop right there. That is going to be our final resting place because now I increases to 3. 3 is less than 3. That's false. So we're done. So this is where we end. All right, let's try another one. Okay, so now we have I equals 0. As long as I is less than 4, we're going to run this code. And at the end of each time we run the code, we're going to add 1 to I. So let's check this robot right here. If we can move forward, move forward. All right, well, we can do that. Then we're going to turn left. And then, okay, it's not going to give us the animation this time. So let's just run through what just happened there. We moved forward, we turn left. As long as we can move forward, we move forward, which we can here. So we ended up in this square and then we turned right. So now we're facing up again. Then I increases in value from 0 to 1. Then we do it again. If we can move forward, we move forward. We could move forward there. So we're up here. We turned left. We weren't able to move forward because this barrier's in the way. So we turn right again. So now we're still facing up, but we're in this square right here. then I increases to 2. Then everything runs again because 2 is less than 4. We move forward, we turn left, we move forward, we turn right. So now we're right here facing up. All the if statements came back true that time. We increase the value of I to 3 and we run it again. If we can move forward, we move forward. We can't. So we're still stuck here. We turn left, we move that way, we turn right. So now we're here and a value of I increases to 4 and 4 is not less than 4. So we exit the for loop. So this is where we end at the end of this specific robot scenario. All right, so that was the last one. These are the key takeaways for today that I want you to make sure that you know going into the next lesson. You need to know what a while loop is, and you need to know what a for loop is. A while loop uses a Boolean condition to repeatedly run a block of code. If it is true, it runs the block of code contained within it. This process of checking the condition and running the block of code is repeated as long as the Boolean condition remains true. Once the Boolean expression becomes false, it will stop. And a for loop condenses the parts of a while loop into a shorter statement. Similar to the while loop, once the Boolean expression becomes false, the loop ends. These are really two ways of doing the same thing. The for loop, though, is a little bit more efficient in space in the code, right? All right. So that is it for the day. Make sure that you submit the appropriate assignment on Schoology. But thank you very much for watching. Let me know if you have any questions, and I'll see you next time in class.